Thank you for clicking on the help video. So let me guide you on this sample version of the homework question that you're going to do. So we have a sample of radioactive isotope that has an initial mass of 150 grams here. Now, after 13 years, the sample is going to decay to 57. And our objective here is to figure out, first of all, K, the decay rate, and to estimate this answer to 3 decimal places. Well, the formula to figure out the K, the growth or the decay rate here, not the growth rate, the decay rate is to get the natural log of, I'm going to zoom in here, the amount that we are going to get at some time t divided by the amount that we have of this isotope at t of 0, and then divide that answer by the time it takes us to go from here to there. So in this example here, zoom out now, since it tells us that we are going to take, it's going to take 13 years to go from 150 grams down to 57, we're going to determine the value of K by taking the natural log of 57, dividing that by 150 degrees, 150 grams, not degrees, grams, and divided by the time it takes us to go down to that, so which is 13 years. So this is how we're going to determine the value of K. So all we need to do now is plug it into Desmos and get our answer. So here I have open Desmos, and I'm going to type in my expression. So we have the natural log, and again I want to get the 57 and divide that by the 150. Again that, and I want that to be divided by 13. So make sure that you're outside the parentheses before you click divide again, because I need all of that to be divided by 13 and not this. I do not need this to be divided by 13. That is not going to give us the right value. So this is the correct format. Now we want to estimate this again to 3 decimal places, which you can do by ourselves. But Desmos has this cool ability that if you type in the command round and put the value in parentheses, it will round the number with you. I just need to put a comma down here, and then how many decimal values I want to round it to. So 3 decimal places. You can also do that in a second entry line. So if you don't want to do it there and you want to round again this decimal value, you can also do it like this. Of course, you would have to write several decimal places and then comma 3, more than 3 decimal places, and then put comma 3 to round that decimal value in front of the parentheses, this number right there, and by 3 decimal places. So the comma and then the number of places you want to round that to. But like I mentioned, you can also do that in the one entry line here by typing in the word round, typing in your expression, and then after the expression type in comma and then the number that you want to round your answer to. If you don't put a comma, it automatically by default rounds it to the 0 decimal places. So you need to make sure that you put a comma and then the value. So our answer here will be negative 0.074. So with our answer as that, we're going to now write the exponential decay model for this sample. Since the format for our exponential models is this, well, this one specifically because we're talking about the mass of this thing, we'll use m of t. So m of t is going to be represented by the amount that we start off with, which we're going to begin with 150 grams, e to the k value, which our k value is this number that we got from part A, and multiplied with t. So this is the answer to the second part. And now the answer to the third part. Well, for part C, we want to determine the remaining mass after 14 years. So we want to figure out the mass of this thing when t is 14. So that just simply requires us to plug in the number 14 in for the letter T. All right, so here I've typed this into decimals. Now for this part, I want to round it to the nearest whole number, so 0 decimal places. And again, I have two options. I could just simply type in the decimal value, 53.23. So the answer estimates again to 53. And now finally, let's find the time it's going to take for the sample to decay to 11 grams. So using the answer that we got from part B, 150 e to the negative 0.074 t, we're going to set this equal to 11. We want to get it all the way down to 11. Now, the way that we get the answer to this one is that we're going to start by dividing both sides by 150. Well, let me show you the shortcut first, what the answer is going to be, and then how I got there. So the answer to figure out t is going to always be in the same format. T is going to be the natural log of the ratio of this value here, let me highlight this number here, 11, divided by this number here of 150. So inside this parentheses, you're always going to get the number you want to get to, divided by the number that you currently started off with, which in this case is 150 grams, and then dividing that by this number K. So all of that gets divided by that. So your answer is going to be always in this format. And the reason for that is because this is the way we solve for this. Since we want to isolate this e, we're going to divide by 150. And then e to the negative 0.074 t equals to 11 over 150. So you see, that's how we get that number inside there. Now, how do we get this? Well, we need to eliminate the e. So we're going to take the natural log of the left side and the natural log of the right side. That way this cancels out. Let me continue over here. And on the right, we're going to end up with negative 0.074 t equals to the natural log of 11 over 150. So you see that? Look, here this is that part right there. And well, how do we get this part? Well, that comes from right here. We're going to divide both sides by this number right there. And we get to that answer right there. So, because we're going to be doing this again every single time, the procedure is the same, you can always guarantee yourself that the format is going to be this format here. You just have to be careful that inside here, you put the values in the correct order. If you don't, if you accidentally see, and I'll show you what happens, if you accidentally put this backwards, you're going to see that your function is not defined, that there's no actual answer. So it kind of gives it away when you plug it into decimals. So let's plug it into decimals and see what the answer is, because we want to estimate this. We need to get this again as a number. We won't be able to type this into our answer like we did in yesterday's homework. So here is your answer. And if we want, since we want to round this again to the 0 decimal places, 35.307, again to 0 decimal places is 35. Now let's say that I put this backwards and I was doing this and I was trying to use this shortcut without having to solve it, and I put this backwards and I put 11, okay? Notice that you just simply get the negative value instead of the positive value. And because time, again, is always supposed to be positive, then you'll just simply need to correct your sign. And you see you get the exact same number, just the opposite value of the correct answer. So the correct answer to here, like I said, is 35. And there you have your answers for part A, part B, part C, and part D. I hope this video was helpful, and now tackle your problem.